Welcome back to Exam Help and Care Lesson Center Academy. We are looking at the same physics, tensile stress and strain. We've looked at the definition. We've looked at example 1. Let's go over to a WAEC question, example 2. Now, calm down. It says that a body of mass 11 kg is suspended from a ceiling, a body of mass. It could be anything, don't know, by an aluminium wire. Okay, wire of length 2 meter, that's nice, and diameter 2 millimeter. Still okay, maybe it's a fan or anything. So calculate the elastic energy stored in the wire. Elastic energy stored in the wire. So Young modulus of aluminium is 7.0 times 10 raised to the power 10 Newton meter raised to the power minus 2. Then acceleration due to gravity, that's G, was given as 10 ms raised to the power minus 2. Then we're given pi as 3.14 specific and objective answers. So let's see what we have here, which will help us to solve this question. So, first of all, what was the last thing they said we should calculate? They said calculate the elastic energy stored in the what? Wire. Oh, yeah. The elastic energy stored in the wire. So now, first of all, elastic energy stored is going to be like something where you have kinetic energy or potential energy. So the elastic energy will be half Fe. Half what? Yeah. Fe. You can look at your textbook for this on more explanation on this. I won't fully be able to explain this why the calculation is on. So, but take note that the elastic energy, whenever you are asked any question, you should imply this, that elastic energy is equal to half Fe. So now, don't forget that Young modulus was still involved. So Young modulus formula F over what? E all over what? E over L. I repeat, Young modulus is F over E all over E over L. So now let's break down the parameters one after the other. Now, a body of mass, a body of what? Mass. Body of mass 11 kg. Body of mass 11 kg. Now you ask yourself, mass is not in any of this, but we have force. So now this is what you do. Remember something, that force is equal to what?
Mass times acceleration.
Yeah, mass times acceleration, mg, right? Yes, force is equal to mass times acceleration, mg. Mass, acceleration, that is the force. So that's the shortest way to get your what? Force. Because if you see here, I don't believe there's anything given to you as Newton. Is there anything Newton here?
No.
No. Aside these ones, right?
Yeah.
And that one is advanced, a derived quantity. So now let's go. First of all, our mass.
So I thought it's normally MA.
Yeah. You can use small letter A.
Oh, G.
Yeah, small letter G. Sorry, not. So because of this, it was given specific. So mass, I am not going to write all the spellings. So M for mass, please take note, because we don't have much time. M for mass. Mass is 11 what?
Kg.
Kg. G, acceleration due to gravity, is given to 10 ms raised to the power minus 2. So what I'll do here, the force is 10 times 11. 10 times 11 will give us what? 110 Newton. That is our what? Force. So take note of that. So we have gotten force. Now, from a ceiling by an aluminium wire of length 2 meter, right?
Yeah.
So length is given as what? 2 meter. Well, length 2 meter. Now, and diameter These guys are very funny. And diameter 2 millimeter. Are you with me?
Yeah.
Now diameter, D for diameter, is giving us what? 2 millimeter. Now we're going to convert this to what? To meters. So we say 2 all over what? 1000. Which should be giving us 0.002 if I'm correct.
Yeah.
Yeah. You just divide it with that and it will give you that. Alright. Now, remember that at times the force is equal to the weight at times. Like you can say F is equals to W, W is equals to mg. That's weight on Earth. So now, but I don't think we need all those things here because what we're interested on is FEEL, right?
Yeah.
Yeah. So now from this, we are going to use this for cross-sectional area because of, that reminds me, this is not supposed to be E, but that's supposed to be what? A. So this should be F over what? A over what? EL, right?
Yeah, question.
Yes. So that's the correction. So please take note of that. That Young modulus is equal to F over A all over EL. So as you're writing the parameter, that's why you have to learn it by heart. Don't just cram. Learn it. Learn it. Once you are learning, you will be able to recall that there's an error somewhere. So I've obtained that one. So now, cross-sectional area, we have to apply some mathematics principles here. So from this D, and they gave us something about 3.14, right?
Yeah.
Now, the area now, we're going to do something mathematical. Wherever you're not given something and you're looking for area of something in mathematics, you're not given the radius. There's a formula you apply. The formula is pi d square all over what? 4. Pi d square over what? 4. So this is the formula we are going to use. Pi d square over what? 4. Maybe we'll talk about this majorly on circles later and we'll show you the relationships. Just remind me, we'll do something on that. Now, what is our pi? Pi is given as 3.14 here, specific.
Okay.
3.14. Then times our new diameter, this new guy is 0.002 all squared. All over what? 4. Good. Now, let's proceed. 3.14 times 0.002 squared.
That is 0.004.
0.004. Are you sure? Check with your calculator, please, and confirm.
It's given us 5, 0, and 4.
Okay, clear?
Yeah.
Clear your last memory. Let's go. 0.002 squared.
It's given us 5, 0 before 4.
Good. 5 zeros before 4.
Yeah.
That is 0. That should be like saying 4 times 10 raised to the power minus what? 6.
6.
Right? So I'm going to have
Let's start ready.
1, 2, 1, 2, 3, 4. I'm getting 5.
Then 4.
Then 4.
Yeah. Because in standard form here is 4 points.
4 times 10 raised to the power minus 6, right?
Yeah.
Good. So we should have 5 zeros, right?
Yes.
Then all over what?
All over 4.
All over 4. Good. Now let's go. Let's continue. 3.14 times all this. Then you divide by 4. 3.14 times 0.004 divided by 4. Honestly, let's just look at something funny here. With our calculator, look at this. 3.14 times 4 times 10 raised to the power what?
Minus 6.
Good. Alright. All divided by 4. Funny enough, 4 cancels 4. Are you seeing?
Yes. That's
So,
what the calculator is giving.
Just save your energy. 3.14 times 10 raised to power minus 6. Good. So we have got our cross-sectional area. So good one. We've got cross-sectional area. So now, since we have gotten cross-sectional area, which of the parameters do you think is still left from the Young modulus?
Force.
Force has been gotten. Our new force is 10 Newton, 1110,
Okay.
110 Newton, pardon. Then cross-sectional area, this.
Is main extension.
Then length 2 meter, and this one should be in meter now, right?
Yeah.
Then we are looking for what? Extension. So it means that after looking for extension, then we will now apply to elastic energy formula to get our final answer. So let's go. Y F over A all over what?
E over L.
E over L. I won't just put everything immediately. What I'll do is I'm going to make subject of the formula so that it will be easier for me. Because if I put numbers immediately, it will all be what? Stressed. You get that?
Yeah.
So now y over 1, so this times this goes this way. So y brackets, I repeat, kind of cross multiply is what we are doing here.
Okay.
So your modulus with E L goes same 1 times F A F over what? A. So we're not going to times this with this, but if you like, if you want, we can. Because I think this is the denominator and this is the numerator, right?
Yeah.
Yeah, and what we're looking for is what?
Extension.
Extension. So let's say YE over what? L equals to F over E.
Still gonna do cross multiply.
So, which means
Do cross multiply.
YE is equals to F over A, put it in bracket, because this guy is going to meet this guy, right?
Yeah.
So it will be times L, right?
Yeah.
Good. Now, since it's times L, we are left with YE equals to this. So we'll now divide both sides by what?
By Y.
By Y. Very good. Divide both sides by Y by Y. So this goes, this goes. So I'm going to wipe this out. So we continue from here. So we cancelled Y, and we're left with EF over A times L. We cross multiply this to this one, this to this one. So remember that we have something like L, yeah. So this is over 1. So if you times, you have that E is equals to FL over what? A. Then you have divided by what? Y, right?
Yeah.
Then over 1. So E is FL all over A times
1 over
1 over Y. So this should be giving us FL over AY, right?
Yeah.
So E is equals to, our F is 1110, if I'm not mistaken, right?
Yeah.
Times length should be 2.
Yes.
Yeah, 2. Then all over our A is 3.14
Times 10 raised to power minus 6.
times 10 raised to power minus 6. Then our Young modulus was given as 7.0. That's times now.
Yeah.
0 times 10 raised to power minus, oh no, 10 raised to power 10, not minus, right? Yeah, 3.14 times 10 raised to power minus 6, that is for our cross-sectional area. Then the question where we wrote it says young modulus was given as 7.0 times 10 raised to the power 10 Newton meter raised to the power minus 2. So now we are going to perform some things here. I didn't mean performing magical. Please. We are not performing any magic. We are just doing arithmetic expressions here. So these times this will give us 2 times 0, 0. 2 times this guy, 2. 2 times 1 is what? 2. That's 220. So 3.14 goes with 7.0. Then times 10 raised to power. We will not be doing long journey now. We'll just say minus 6 plus 10. Right? So minus 6 plus 10 gives us what?
Positive 4.
Positive 4. Very good. So take that in your mind that we did minus 6 plus 10. The bases are the same, powers of 10, add the powers, and you're good to go. So this guy will go upstairs because he's fond of going up every time. So let him go upstairs and give us 3.14 times 7.0, please.
That is 21.98.
Okay. Come again.
21.98.
21.98. Are you sure? Did you clear last memory?
Yes, I did.
Okay, 21.98 times 10 raised to the power what?
Minus 1.
Minus 4. This guy has gone up. Alright. So now we do 220 divided by what? 21.98. So scratch that and let me know what you got.
That's giving us 10.009.
10.009. 009.
Yeah.
Okay. Times 10 raised to the power what? Minus 4. Right?
Yeah.
Okay. If I take this,
it can be 10.1.
assuming saying this is 009, right?
Yeah. Can that be 10.01?
That's just 10.0. Let's make a whole number perfect. Are you with me?
Yeah.
Okay. So I'm going to have nearest whole number 10 times 10 raised to the power minus what? 4. And this guy is the same thing as
1.0.
1.0 times 10 raised to the power what?
Minus 2.
Yeah. But let's make it easier for everybody. This guy is the same thing as 10 raised to the power 1 plus minus 4.
Yeah.
So it will now be
1.0.
1.0. Okay, let's say 1.0 first of all. Times 10 raised to the power 1.
1 plus.
This is the same thing as this.
Yeah.
Then
plus open bracket.
Plus minus.
Yeah.
So that's minus.
Yeah. 4.
4. So plus minus 4. This should give us 1. 1.0 is the same thing as 1.
Yeah.
Okay, but let's write it for writing sake. Times 10 raised to the power what?
Minus 3.
Minus 3. Okay. So I think this is a final answer for E. Are you getting me?
Yes.
Then it should be in meters, right?
Yeah.
Yeah. So now, in ordinary form,
okay,
in the ordinary form, this 1.0 times 10 raised to the power minus 3 is going to be 0.001 meter. True or false?
True.
Because we have 1, 2, 3.
Yeah.
So there's now 1 times 10 raised to the power minus 3. So this is what we'll be interested. We'll be using this, right?
Yeah.
Okay. So now we'll now use the last formula that says
elastic energy
equals to, that's elastic energy equals to E half times what?
Force and extension.
Force times extension. Very good. So to take this off, remember the question lastly says calculate the elastic energy stored in the wire. Elastic energy stored in the wire. So elastic energy stored in the wire is half F E. So E is equals to 1/2 times 1110 times
0.001.
0.001. If you're still scared, you can use your 1 times 10 raised to the power minus 2 if you like. But let's continue. 0.001, right?
Yeah.
I'm going to have this and this. So 2 here, 1, 2 in 1110. Give me what it keeps.
2110.
Yeah. 2 in 11 should be 5, remainder 1. That should be 55. If I'm not mistaken.
55.
Because 2 times 5 is 10.
Yeah.
2 times 5, 10 plus that. So 110. So that should be 55 times 0.001. Alright. Do that with a calculator for us so that we'll be fast. 555 times 0.001.
Like giving us 0.055.
0.055. Okay, double 5.
Yeah.
55. So since it's energy, SI unit for energy is always joules. So converting this to standard form will be 5.5, right?
Yeah.
Times 10 raised to power
minus 3.
minus 2.
2.
Yeah. Minus 2 what?
Okay, yeah.
Joules.
Minus 2 joules.
Yeah. So the correct options, if you check from what we've said, was actually B. So B is the correct option. B is 5 point. Let me say option B. Option B. So option B was 5.5 times 10 raised to power minus 2 what? Joule. So that's the final answer. So it just takes you little time. So learn it by heart. Be persistent. Do it step by step, and we believe that you keep on learning one after the other. So there's no way we are going to teach you all this without giving you an assignment. That's sure. So you have not to be scared. I'm giving you an assignment right now. So this is your assignment. We've tried excessively, so we're giving you this as your assignment. Please do justice to this. Remember, stay calm. It's not going to be stressful. Like the question says, y of length, the length has been given, and diameter 2.0 millimeter extends by 0.25 millimeter when a force of 50 Newton was used to stress it from its end. Calculate D. A. Stress on the wire. B. Strain in the wire.